All right, so we're kind of making a big jump in our textbook and jumping all the way to chapter 12. And the reason being, chapter 12 is all about the mathematics of voting and politics. And Kent and I thought it would be a good thing to talk about as we come up on a large election. So we're going to start with 12a. Voting, does the majority always rule? We'll define majority rule, and then we'll identify a few other voting methods for 3 or more candidates and discuss how they work. All right. So the simplest type of voting involves only 2 choices, and with majority rule, the choice receiving more than 50% of the vote is the winner. Some properties are listed here, so every vote has the same weight. There's symmetry between the candidates, and all this means is that if one loses a vote, the other would gain that vote because there are only the 2 choices. If a vote for the loser were changed to a vote for the winner, the outcome of the election would not be changed. So that just means if more people voted for the person who won, they would still win, which might seem relatively obvious, but we're going to see in a plurality, which is what we use in the United States, or it's kind of a partial plurality, partial majority, because we have this thing called the Electoral College. Certain types of pluralities, a vote for the loser being changed to a vote for the winner can change the entire outcome of the election. All right, so let's look at an example. These are the results of the 2000 presidential election, where we had George W. Bush versus Al Gore versus Ralph Nader versus Pat Buchanan. And these were just some third-party candidates you may or may not have heard of. And we're just going to kind of analyze this table. So in the United States, we have the Electoral College. I'm sure you've talked about it in your government class. And there are 538 votes in the Electoral College. And the way it works is that different amounts of electoral votes are distributed to states by population. And in the states, whoever wins the popular votes, it's tradition that that candidate gets all the electoral votes for that state. And so you then have to win a majority of the electoral votes to win the presidency. But that differs from the popular vote, right? As we see here in this outcome, in the year 2000, the popular vote was very close between George W. Bush and Al Gore, although Al Gore actually won more of the popular vote. So about 500,000 more votes than George W. Bush. So 543,895. So Gore won the popular vote over Bush by more than 500,000 votes. And if we break that down into percentages, Gore won 48% of the popular vote. Bush won 47% of the popular vote. So neither of them had a majority, right? But in the electoral votes, Bush happened to win the appropriate states that had more electoral votes. He won 271 of the 538 electoral votes, giving him a slight majority and winning him the presidency. All right, so there are a few variations on the majority rule. There's something called a supermajority, and that's when more than a majority, so more than 50% is required to end the election. A couple examples of that. A 60% supermajority is required to end a filibuster in the U.S. Senate. Filibusters are something that is a kind of a hot topic in politics right now, and we'll actually define what that means. And a 2/3 supermajority, so about 67%, is required by both the House and the Senate to amend the Constitution. So supermajority is just a generic term that means more than a majority. and it could be various values above a majority. All right, so let's evaluate the outcome in each of the following cases. So A, of the 100 senators in the U.S. Senate, 59 favor a new bill on campaign finance reform. The other 41 senators are adamantly opposed and start a filibuster. Will the bill pass? So a filibuster is basically when a member of the Senate, if they want to speak, they're given an unbounded amount of time to do so. And so if a minority doesn't want a bill to pass, they can just threaten to talk forever. And they can just keep continuously talking until those in the majority say, all right, we won't pass the bill. So they need as we mentioned here, you need a 60% supermajority to end a filibuster in the U.S. Senate. But only 59 out of the 100 senators favor the new bill. So 59% is not a supermajority. So the answer is no, the bill won't pass. Because the other 41 senators, it doesn't happen very often anymore where it actually goes to a filibuster, although there was one a couple years back where the senator was actually talking for like 8 hours on end. But usually what'll happen is they'll threaten a filibuster and that'll kill the bill right there. All right, B, a criminal conviction in a particular state requires a vote by 3/4 of jury members on a 9-member jury. 7 jurors vote to convict. Is the defendant convicted? 3 out of 4 is exactly 75%. 7 out of 9 is approximately 78%. So yes, the defendant is convicted. All right, couple more scenarios. I'm going to look at C here. A proposed amendment to the U.S. Constitution has passed both the House and the Senate with more than the required 2/3 supermajority. Each state holds a vote on the amendment. The amendment garners the majority vote in 36 of the 50 states. Is the Constitution amended? So one thing I hadn't mentioned yet is that we did mention that to amend the Constitution, you need a 2/3 supermajority in the House and the Senate. But what you also need is 3/4 of the states, at least, to vote to amend. So that's 75% of the states also have to vote to amend. So in this case, they said 36 out of 50 of the states voted to amend. And if we pop that into our calculator, 36 out of 50 is approximately 72%. So no, they did not get the supermajority of states, and no amendment. All right, D, a bill limiting the powers of the president has the support of 73 out of 100 senators and 270 out of 435 members of the House of Representatives. But the president promises to veto the bill if it'll pass. Will it become law? So another little caveat that I need to tell you is that you need a supermajority in the Senate and the House to pass this bill. But to override a presidential veto, you need a 2/3 supermajority in both the Senate and the House as well. So let's see what we have. 73 out of 100 for the Senate. That'll do it. That's 73%. So that's more than 2/3, which is about 67%. In the House, we have 270 out of 435, which is only 62%, which is not going to be enough to override a presidential veto. So will the bill become law? The answer is no. Okay, we're going to look at another table showing the results from 3 major candidates in the 1992 U.S. presidential election, and we'll analyze the outcome. So Ross Perot was famous for being the independent to get the most popular vote in any presidential election. And so he really divided the undecided voters, pulled them away from Clinton and Bush. And the question is, could Bush have won if Perot had not run? And so Bill Clinton won 43.3% of the popular vote, which is not a majority, but it's the most of any of the 3 candidates. So we call that a plurality. Whoa. So if some percentage, so if Perot didn't run, we're going to expect that 19% has to be divided between Clinton and Bush. And if, let's look at the extreme case, the whole 19% goes to Bush, 37.7 plus 19. If we add it on, that's going to give me 56.7% of the vote. But he wouldn't even have needed all of those to get the majority. That's well above the majority. So he only needed an additional 12.3% of the vote to get to the majority stake. And so 12.3 out of 19, that's 65% of Perot's voters. So if 65% of the Perot voters voted for Bush, he may have won the popular vote. But as we saw in the 2000 election, winning the popular vote does not guarantee winning the election. All right, preference schedules. Tabulating results from ballots requires a special type of table. We call that a preference schedule, and that tells us how many voters chose each particular ranking order among the candidates. All right, so as mentioned, if there's only 2 candidates, the most simple voting method is majority rule, but that's not the case in most elections in the United States. So we're going to go over some important voting methods for situations where you have 3 or more candidates. The first one is called plurality, and this is just where the candidate with the most first place votes wins. So these are going to be important to write down and know. Second one is a single runoff method, and that's where you take the 2 candidates with the most first place votes and you have a runoff. So you have a second election where everybody has to vote for one of those 2 candidates, and the winner of the runoff is the winner of the election. Third, we have sequential runoff method, and that's where a series of runoffs is held, and you eliminate the candidate with the fewest first place votes at each stage. So I think of this as kind of the slowest buffalo method. So there's that saying, you don't have to be the fastest buffalo, you just don't want to be the slowest, because the slowest one gets picked off. That's the case here. The person with the worst record gets eliminated from the election. You have another round. The next person with the worst record gets eliminated until you're down to 2 candidates. You do your final runoff, and the winner of the final runoff wins the election. So similar to the top 2 runoff method, except this one can have more rounds if there are more than 3 candidates. Okay, we have a point system, sometimes called the Borda count, and points are awarded according to the rank of each candidate on each ballot. So first, second, third, and the candidate with the most points wins. So you would get a ranking of the candidates. So the electorate, us, that are doing the voting, instead of just putting a check mark by somebody's name, instead we rank our first choice, our second choice, and our third choice. And the first choice gets the most points, the second choice gets the second most points, the third choice only will get 1 point if there are only 3 candidates. And then we total up everybody's points, and whoever has the most points wins. So this sort of system lends itself to getting, I don't want to say a mediocre candidate, but less extreme candidates. So candidates who a lot of people rank their second choice tend to be favored in the Borda count system. And then we have pairwise comparison, sometimes called the Condorcet method. And that's where the candidate who wins the most pairwise, which is head-to-head contest, is the winner of the election. So this is where everybody gets paired against each other. You see who wins the most of those, and they win the whole election. All right, so let's do some work with some of these. All right, so here we look at a preference schedule, and it's for a 3-candidate election. So we have candidates A, B, and C, and you can see the way the voters have ranked them. They've only ranked them in 3 ways. So they ranked them in ABC, that was 14 voters ranked it that way. CAB, 12 voters ranked it that way. BCA, 10 voters ranked it that way. We can total up that bottom row to see the total number of voters, which is going to be 36 voters, right? All right, and so what we want to see is, can we decide this election using pairwise comparisons? And so what we need to look at is all the possible head-to-head combinations. So let's start with A versus B. And the way this works is you're going to look at each column, and whoever is ahead or the highest ranked in that column wins all the votes in that column. So looking at column 1, A is ranked first above B. So A gets all 14 of those votes. The second column, A is still ranked above B. I know C is ranked above A, but since we're just doing a head-to-head of A versus B, we don't need to worry about C. So A is ranked above B, so A also gets those votes. And then the last column, B is ranked above A, so B wins those votes. So the winner of that head-to-head runoff was A. A had 26 votes, B had 10. All right, now let's look at another head-to-head. We could look at A versus C. We go back to each column and we do the same thing. Whoever's ranked the highest wins all the votes. So A versus C in the first column, A wins, gets the 14 votes. Second column, C wins, gets 12 votes. Third column, C wins, gets 10 votes. So in this head-to-head, C beats A. And then the last pairwise comparison is B versus C. First column, B wins, gets those 14 votes. Second column, C wins, gets those 12 votes. Third column, B wins, gets these 10 votes. So B won that head-to-head, and that's all the possible head-to-head combinations. So if we look at this, who won the most head-to-head combinations? Well, A won 1, B won 1, and C won 1. So pairwise comparisons won't always decide an election, and this is called the Condorcet paradox. So the answer to their question is no. We can't find a winner through pairwise comparisons because they each win one of the head-to-head contests. And thus we have a situation involving the Condorcet paradox. All right, so now we're going to do answer some basic questions about a little bit more of a complicated preference schedule. Here is one that has 5 candidates, candidates A, B, C, D, and E. And these are the rankings of those members among voters. So there happen to be 1, 2, 3, 4, 5, 6 different ways these candidates were ranked in this election. And we're just going to answer some of these questions. How many voters ranked the candidates in the order E, B, D, C, A? So you just want to find the column that matches that order vertically from top to bottom. E, B, D, C, A. This column right here, the second to last, and there were 4 voters that ranked the candidates in that order. How many candidates had E as their first choice? Well, there were the 4 that I just circled, but there's another one that has E as their first choice, so an additional 2. So there were 6 voters who had candidate E as their first choice. And then how many voters preferred candidate C over candidate A? Oops. So what we want to do is just go down the columns, and we're going to take the columns that have candidate C ranked higher than candidate A. So column 1, no, A is ranked first. Column 2, yes. C is 4th, A is 5th, so C is ranked higher than A. Column 3, yep. Column 4, yes, C is ranked 2nd, A is ranked 5th, so we're going to add that. Column 5, yep. And column 6 as well. So we're just going to add up, what is that, 22, 31, 35, 37 voters preferred candidate C over candidate A. All right, so what we're going to do is take that same preference schedule, and we're going to find the winner using each of the 5 voting methods we've covered. So we'll start with plurality. Plurality is just the candidate who has the most first place votes. So all we care about is first place votes here. So A has 1 column where they win first place. They get 18 first place votes. B also has 1 column. They win 12 first place votes. C, also 1 column. They get 10 first place votes. D gets 9, and then E has 2 columns. 4 plus 2 is 6 first place votes. So whoever has the most of those wins, which makes A the plurality winner. All right, let's talk about single runoff. Well, if we go back to the last page, single runoff, we want to take the top 2 candidates. So we would take candidate A and B, and then we would run them head to head against each other. A versus B. And then whoever gets the most votes at the end of that is the overall winner. So that means these candidates who voted for C, D, and E, they're now going to have to vote for either A or B. All right, so let's see. Candidate A gets the 18 in that first column. Candidate B gets the 12 in that second column. And then candidate B ranks higher than candidate A in the third column, so they get those 10. B also ranks higher than A in the next column, so they get these 9. B is higher than A in the 5th column, so they get those 4. And then B beats A again in the last column, so they get 2. So A gets 18, whereas candidate B, when we add all those together, 22, 31, 35, gets 37. Candidate B is the winner by single runoff. Okay, so sequential runoff will work like this. Here are the rankings of just the first place votes. So remember, I called this one the slowest buffalo runoff. So what we do is eliminate the last place candidate, and then we run a new round until we're down to 2. We run our final round, and then whoever wins that final round wins the whole thing. So E is in last place. So they're getting eliminated, meaning we're going to have to redistribute their votes. So what you want to do is go through your preference schedule. You're going to get rid of all the E's. And then everything below that E will shift up in preference. Oops. Okay. So now let's look at what would happen if we look at a race just between A, B, C, and D. So I have another table that I'll show you where we've actually eliminated E and we've shifted all the rows up. All right, and that's this one down here. So now I've eliminated all the E's. I've taken out all these highlighted green E's, and I've shifted up. So let's see what our rankings would look like in the second round. So A gets these 18, but doesn't get any more. So A, round 2, still gets 18. Let's look at B. B gets 12, but then it also gets these 4, because now B is in first place in that column. So B now is at a total of 16. So look at C. C gets these 10, and also these 2. So C is now at 12. And D is still just stuck with 9. D is the slowest buffalo on that round. So now we go through and we eliminate all the D's. D's gone. And we shift all the rows up that are below those D's. Show you what that new table looks like. So now it's a lot smaller, and we're just looking at a race between A, B, and C. And so let's go through. Let's see, A still only has the one row of 18. So this is now round 3. A still only has 18. B has 2 rows, or 2 columns. They have 12 and 4. So B still has 16 votes. But now C is moving up. Candidate C has won 3 columns now, 10, 9, and 2. They're at 21. All right, so now B is the slowest buffalo. And we have our final round of A versus C. So all the B's get eliminated. Move all the rows up. We look at A versus C. And you can see that A maintains just the 18. C picks up all the rest of those votes. So C picked up all of B's votes. A just ended up with the 18. C now has 37, so candidate C is our winner by sequential runoff. All right, so for the Borda method, you're going to assign point values based on how many candidates you have. So if you have 5 candidates like we do here, then a first place vote gets 5 points, second place gets 4 points, third place gets 3 points, and so on. So first place, 5 points, second, 4, third, 3, fourth, 2, fifth, 1. And what you're going to do is go through each column for each candidate and total up how many points they get. So candidate A got 18 first place votes. So I'm going to multiply 18 by 5 plus Then if you look at candidate A in every other column, they're in 5th place. So I'm going to add up the total votes that they had there. I think it's 37, 22, 31, 35, 37. So they had 37 5th place votes for which they get 1 point. So A's total is 18 times 5 plus 37 times 1. Which is 127 points. All right, let's look at candidate B. Candidate B gets 12 first place votes. So I'm going to do 12 times 5. There are 2 columns where B is in second. So B gets 14 second place votes. So plus 14 times 4 plus. All right, candidate B, no third place votes. He's in 4th place in 2 columns. So he got 9 plus 2. He got 11 4th place votes, for which he gets 2 points for each of those. All right. And then finally, candidate B got 18 5th place votes. So 18 times, he gets 1 point for those. Just popping this in the calculator real quick. All right, candidate B, 296 points. Let's look at candidate C. I'll just try and go in order again. Candidate C got 10 first place votes, so I'm going to do 10 times the 5 plus, let's see, second place, 11. So 11 second place votes, so 11 times 4 points for each of those. Third place, none. Fourth place, so add those up, that's 34. 34 times we get 2 points for 4th place, and then no 5th place votes. So 10 times 5 plus 11 times 4 plus 34 times 2. It's 162. Oh, I just noticed that I made a calculation error on candidate B. I did 14 times 14 instead of 14 times 4. All right, sorry. Hopefully you checked me on that, but this is only 156 for candidate B. I screwed it up in my calculator here. I put 14 instead of 4. All right, let's do candidate D. First place votes, candidate D has 9. So 9 times 5 plus. Second place votes, candidate D has 18. So 18 times 4. Third place votes, candidate D has a few of those. 12 plus 4 plus 2, that's another 18. And then 4th place, candidate D has 10 plus 10 times 2. And no 5th place votes. So candidate D gets 9 times 5 plus 18 times 4 plus 18 times 3 plus 10 times 2, 191. All right, and then last we're going to do candidate E. So candidate E gets 6 first place, so 6 times 5 plus 12 second place, so 12 times 4 plus 18 plus 10 plus 9. So 28 plus 9 is 37. third place votes, so 3 points for each of those. No fourth place, no fifth place. So 6 times 5 plus 12 times 4 plus 37 times 3, 189. So our winner by Borda count, candidate D, with 191 points. Okay, this is the last one. This is our pairwise comparisons, or the Condorcet method. So this is where we look at each candidate head-to-head, and then we'll determine who won the most head-to-head matches, and they win the overall election. So over here, I'm just gonna keep track of the number of wins each candidate gets, and off to the right, let's go over the possible head-to-head comparisons. So we have AVB, AVC, AVD, AVE. Then we have BVC, BVD, and BVE. Then we have CVD and CVE, and I think that covers everything. So each time we go through, we're just going to pay only attention to the 2 candidates. Whoever ranks highest in that column gets those votes. So let's do AVB. Column 1 goes to A. Candidate A has 18. Let's see. Let's do this. To make this one a little easier, we can add up the total number of votes. So 18 plus 12 plus 10 plus 9 plus 4 plus 2 is 55. And that way, now all I have to do is pay attention to one candidate, and if they get over half the 55 votes, then they're the winner. Since it's head-to-head, it's just majority wins, right? So I'm just going to focus on A here. So A gets 18. A doesn't win the next column. A doesn't win the next column, or the next one, or the next one, or the next one. So A only got 18 votes, which means B got the other 37. B wins. All right, B has 1 win. AVC. Again, A gets 18, but then A is in last place in all the other columns, so C gets all the others, so C wins on that one. So C has 1 head-to-head matchup win. AVD, same deal. A has 18. D gets every other column because A is in last place in all of them. AVE, same deal. E wins because A is in last place on all but the first columns. So we got a win for everybody but A there. Now let's look at BVC. So I'm just going to look at candidate B versus C. Candidate B does not win that first column because C is higher ranked. B does win these 12. Does not win the next column. Does not win the next column. C is ranked higher. Does win these 4. And does not win the last column. So candidate B only got 16 votes, which means candidate C got the remainder, which is 39. So C wins that one. All right, let's look at BVD. Need to mark that tally down for C. BVD. B wins does not win the first column, does win the second, does win the third, does not win the fourth, does win the fifth, does not win the sixth. So, this is a close one. In this one, B gets 26, which is still less than half of the 55 votes, right? So D wins that one. All right, BVE. B does not win this one. Does win the next one. Does win the next one. does not win this one, does not win this one, does not win this one. Only 22 votes, so E wins that one. All right, only 2 more. So now we're going candidate C versus candidate D. I'm just going to pay attention to the wins for candidate C. C ranks lower on the first column, lower on the second column, higher on the third column, lower than D on the fourth, lower than D on the fifth, higher on the sixth. So candidate C only gets 12 of those votes, so candidate D wins that. And last, oh, you know what? Sorry, we did miss one. This is not the last, this is the second last. We also have D versus E. All right, so C versus E. C does not win the first, does not win the second, does win the third, does win the fourth, and does not win the fifth or sixth. So C only gets 19 votes, so that's a win for E. And now it's DVE. They're head-to-head. So looking at the first column, does D win? Yes. Second column, E wins. Third column, E wins. Fourth column, D wins. Fifth and sixth, E wins. D gets 27 of the 55 votes. So close, but E pulls that one out, and E is your overall winner. Candidate E is the winner by pairwise comparison. So the big deal here is we use the same preference schedule, and in all 5 different types of voting, a different candidate won. We had a candidate A won plurality, and a different candidate won each other voting method. So there is an issue with voting when you have more than 2 candidates in which there is no inherently fair way to do it. It depends on what you want the outcome of your election to be like. For example, points, right? Nobody was like super into candidate D. A lot of them were ranking him somewhere in the middle, but because he got so many second place and third place points, he was elected. So it elects less extreme candidates, basically. Whereas plurality tends to elect more extreme candidates. All right. So here's your student example, a little bit of a simpler preference schedule, only 3 candidates, but I want you to see if you can go through and tell me who wins through the Borda method. That's points, single runoff, and sequential runoff.